3I Atlas. Just activated brakes. NASA confirms artificial maneuver. When NASA confirmed that 3I Atlas had slowed itself down, everything changed. What began as an ordinary comet became a cosmic enigma, a silent visitor defying physics, whispering through the void. Signals, secrets, and a maneuver no natural body could perform. If it wasn't nature, then who or what just hit the brakes out there? The silent arrival. For months, the telescopes sweeping across the northern sky had watched a faint, forgettable blur of light move against the tapestry of stars, one of thousands that came and went in the nightly data stream. At first, nothing about it stood out. The object was faint, slow, and cold, the sort of speck astronomers cataloged, logged, and rarely spoke of again. It was April 2024 when the Pan-STARRS array in Hawaii tagged it as another inbound comet, a routine celestial traveler passing briefly through the solar system before drifting back into the deep. They called it 3I Atlas, a designation that meant little more than its discovery order and the survey that found it. To most, it was just another rock in the dark, but space has a way of hiding its secrets behind ordinary masks. At first, the numbers made sense. Its orbit was open, a hyperbolic trajectory, the hallmark of an interstellar visitor, much like the enigmatic Oumuamua before it. Its albedo and spectrum suggested ice and dust, nothing alien, nothing artificial. In the flood of nightly reports, 3I Atlas slipped quietly into databases, drawing no headlines, no sleepless nights. Yet among the algorithms and cold data, something subtle began to whisper. A small inconsistency buried within the mathematics of its motion. Astronomers at first blamed calibration errors. Tiny deviations in observed versus predicted positions can come from solar radiation pressure, jets of vapor from sublimating ice, or even atmospheric distortion on Earth. But the more data they collected, the less the object behaved as it should have. Its trajectory didn't just drift, it adjusted as if correcting itself. Still, no one wanted to believe it. After Oumuamua, no scientist wished to reignite the public frenzy of alien probe theories that had embarrassed institutions only a few years before. Teams quietly rechecked their models, adjusted their assumptions, and filed notes into private logs. The object remained statistically insignificant, until, one night, an automated alert flagged a shift in velocity that didn't match any known natural cause. The alert went unnoticed for days, buried beneath higher priority detections. When it was finally reviewed, the numbers forced a pause. The change was minuscule, a fraction of a meter per second, yet the direction and timing were deliberate. Like a subtle tap on cosmic brakes, the data was shared across observatories under routine classification, nothing marked urgent. But within days, whispers spread through private Slack channels and encrypted academic forums. Could be non-gravitational, one message read. Or maybe controlled, replied another. A cautious debate ignited, hushed but electric. Still, to the outside world, 3I Atlas remained invisible, a faint traveler sliding silently toward the inner system. No press releases, no NASA statements, just a single object spinning in the dark, following a path that no comet should. For those watching closely, it wasn't the brightness that mattered. It was the stillness. The object seemed aware of its own motion, as if it understood when to slow down. And for the first time since Oumuamua, the night sky felt alive again. A stranger among comets, when the first high-resolution data began streaming in, the assumption was simple. 3I Atlas was another frozen relic from the outer galaxy, a comet carrying whispers of alien chemistry. But almost immediately the numbers began to argue with the narrative. Its light curve, the subtle pulse of brightness as sunlight scattered across its surface, refused to behave like any known comet. Instead of the rhythmic, predictable flicker caused by rotation and jets of vapor, 3I Atlas shimmered with irregular precision, like a strobe that knew what it was doing. Spectrographic analysis deepened the confusion. The readings were dry, literally. The usual spectral fingerprints of a comet, water, carbon dioxide, organic volatiles, were missing or muted to near absence. Whatever it was made of, it wasn't shedding ice or dust as it neared the sun. The coma, that ghostly halo of vapor every comet wears like a crown, never formed. It was moving through solar heat like a stone, not a snowball. NASA's Planetary Defense Coordination Office logged the findings with quiet curiosity. They'd seen anomalies before, dormant comets, rocky interstellar debris, even carbon-rich asteroids masquerading as something else. But this one didn't fit any template. The object's reflectivity hinted at something metallic, while its rotation period, a steady, exact 8.2 hours, held unnerving consistency, as though governed by a mechanism, not momentum. By mid-May, multiple observatories had joined the study. The European Space Agency's Gaia telescope, the Subaru Observatory, and NASA's own Deep Space Network all locked in their sensors, trying to synchronize the data. Each confirmed what the others whispered. 3i Atlas was not tumbling chaotically like a natural body. Its axis was stable, its spin unyielding. Theorists began to drift into uncomfortable territory. Could an object maintain such precision through natural evolution? Could tidal forces, collisions, or outgassing ever produce a rotation that regular? The odds were vanishingly small. Some likened it to a cosmic gyroscope, a construct that seemed to defy the entropy of deep space. When astronomers compared the trajectory to the Oort cloud's gravitational influence, another riddle emerged. 3i Atlas appeared to be performing micro-adjustments to its path, nothing dramatic, just enough to maintain a calculated angle of solar approach. The pattern wasn't random. It resembled an optimization, as if the object was seeking the perfect vector between Earth and Mars for observation or passage. The debate fractured into two camps. The first insisted on caution. Non-gravitational forces, they said, maybe internal gas vents or asymmetric heating. The second group, smaller but louder, pushed a dangerous word back into the scientific lexicon. Artificial. That word alone could end careers. No one wanted to be the next Avi Loeb, the Harvard astrophysicist who'd suggested Oumuamua might have been an alien light sail. Yet as data kept pouring in, the silence grew harder to maintain. 3i Atlas wasn't just unusual. It was consistent in its impossibility. NASA's Jet Propulsion Laboratory began to receive quiet requests for tracking priority. The Deep Space Network extended its observation windows. Somewhere within the chatter, a phrase began appearing in internal memos: controlled drift. To those outside the classified circles, that meant nothing. But to those inside, it meant everything. Even amateur astronomers started noticing something peculiar. Time-lapse images captured faint periodic dimming, too structured for random rotation, too soft for reflection from a single face. It was as if the object had panels or facets that caught sunlight in intervals. A geometric rhythm in the dark. Still, NASA held its official stance. 3i Atlas was a natural interstellar body exhibiting non-gravitational acceleration due to unknown thermal mechanisms. Polite language for we don't know what's happening, but for those who'd been studying its course since April, denial was no longer a shield. Every new observation peeled back the illusion of normalcy. The universe was vast but not careless, and this object, whatever it was, behaved as if it knew it was being watched. In the deep corridors of data archives, 3i Atlas no longer sat among comets or asteroids. It had earned a category all its own. Unclassified object, Type 3. A quiet label for something that had no precedent, and as it continued its approach, decelerating in ways no rock could, a quiet unease began to grow. The same chill that had once followed Oumuamua. Only this time, NASA was watching closer, because this stranger among comets wasn't just passing through. It was slowing down, When it hit the brakes by early June, the mystery had hardened into data, and the data refused to play along with physics. NASA's Solar System Dynamics Group at the Jet Propulsion Laboratory had been monitoring 3I Atlas through a network of orbital telescopes, carefully plotting its velocity curve as it approached the inner system. At first, the measurements aligned beautifully with celestial mechanics, the object's speed increasing as it fell toward the sun, the inevitable rush of gravitational acceleration. But then, as if a cosmic hand had reached out to press gently against it, that acceleration began to flatten. The curve, smooth, predictable, and universal for every known natural body, began to bend. Astronomers initially blamed the instruments. Space telescopes drift. Calibrations slip. Data gets messy. But cross-checks came in from 3 independent observatories, one in Chile, one in Hawaii, and another from an ESA array tracking the object through the L2 Lagrange point. Every dataset told the same quiet story. 3I Atlas was slowing down. The change wasn't spectacular. There were no cinematic halts, no visible thrusters, no trail of vaporized gas. It was a whisper, a deceleration so subtle it required days of stacked data to confirm. Yet in cosmic terms, that whisper was deafening. Something out there, beyond the orbit of Mars, was losing velocity in a way that defied gravity. NASA's orbital analysts were the first to panic quietly. A deceleration of that magnitude, roughly 0.02 meters per second squared, could not be explained by outgassing or solar radiation pressure alone. The numbers didn't add up. The object wasn't shedding mass, wasn't heating as it should have been, and its rotation remained stubbornly constant. If there were jets of vapor propelling it, they were invisible and perfectly balanced. For context, even comets in full eruption, venting tons of material per second, never produce motion that precise. Nature, after all, doesn't aim. In late June, a classified teleconference gathered a handful of senior astrophysicists, data analysts, and NASA liaisons. The tone was cautious, the language sterile. The central question, are we observing an external force acting on 3I Atlas? No one wanted to answer. Because to answer honestly was to reopen a door the agency had been careful to close since 2017, when Oumuamua had raised the same forbidden specter. Some argued for solar sail dynamics, the idea that 3I Atlas might be an ultra-thin structure, its motion governed by photon pressure. But that explanation died quickly under scrutiny. A solar sail would have accelerated outward, pushed by sunlight. This object was doing the opposite. It was resisting motion, braking. Others floated the notion of magnetic interaction, a charge buildup interacting with solar wind. But the trajectory wasn't aligned with the magnetic field lines. The vectors were off. It was as if the deceleration was internally directed, responding not to external pressure, but to some internal command. A quiet phrase began to circulate through encrypted memos and off-record discussions. Autonomous maneuvering. No one said intelligent. No one dared. The term was radioactive, but the implication was unmistakable. Within days, the Deep Space Network ramped up coverage. Dishes at Canberra, Goldstone, and Madrid tracked 3I Atlas around the clock, watching for any fluctuation in signal reflection. What they found only deepened the riddle: intermittent radar echoes, faint, structured, rhythmic. Not random scatter. Patterns. Telemetry-like, one engineer wrote in a redacted report later leaked months afterward. By mid-July, the object's slowdown had become undeniable. Its velocity relative to the sun had dropped by nearly 5%, far beyond what sublimation or solar drag could produce. Its approach vector was no longer purely ballistic. It was guided. And then, the most unsettling shift occurred. The object began to align itself. In images captured by the Subaru telescope, astronomers noticed that the axis of 3I Atlas, the direction of its spin, was changing slowly, tilting toward the ecliptic plane. Not random tumbling, but a deliberate orientation. In simple terms, it was pointing toward Earth. That realization sent ripples through the agencies tracking it. The alignment could have been coincidence, a natural spin correction, an illusion in the data. But when the rotational axis stabilized exactly on the vector connecting Earth and Mars, coincidence became a hard sell. Inside NASA, the tone changed. What had been a curiosity was now a potential anomaly of interest. Press inquiries were deflected with careful phrasing. Observatories were asked to hold data embargoes until further review. And behind closed doors, a phrase surfaced in one internal document that would later leak into the public sphere. Possible controlled deceleration event. 3I Atlas. The world, of course, heard none of this. News coverage still described it as a strange interstellar comet, a poetic oddity from another star system. But for those working the midnight data shifts, staring at numbers that refused to obey physics, something deeper was dawning, an awareness that the universe might not be as indifferent as it once seemed. Because this wasn't just an object slowing down, it was choosing to, and that single fact, buried in data and silence, would
force NASA to confront a question it had spent decades avoiding.
If something can move against the pull of the sun, who or what is guiding it? 4. Theories and turmoil. When the first reports of 3I Atlas's deceleration leaked into the wider astrophysical community, the reaction was immediate and deeply divided. In science, the unknown is usually greeted with quiet curiosity, but this was different. The numbers weren't just puzzling, they were provocative. The very laws that kept planets in orbit, that predicted the paths of comets and asteroids, seemed to bend around this one object. For many, it was exhilarating. For others, it was dangerous. The first to break ranks were the independent astronomers, unburdened by institutional caution. Forums and private Discord channels lit up with speculation. Some claimed 3I Atlas was the second act in a cosmic pattern following Oumuamua, the first interstellar visitor to challenge human understanding. They pointed to the deceleration data, the absence of a cometary tail, and the stable rotation, arguing that nature alone couldn't produce such order. If Oumuamua was the question, one post read, then Atlas is the answer. Within NASA, however, excitement gave way to quiet containment. Internal communication guidelines were revised. Scientists were reminded to refrain from speculative language in public or press-facing commentary. The official narrative remained fixed. Non-gravitational acceleration due to outgassing or reflective solar interaction. But inside the agency's encrypted servers, the memos told a different story. One report from the Jet Propulsion Laboratory, later leaked in fragments, listed 9 potential explanations for the observed behavior. 8 were natural: sublimation jets, thermal asymmetry, magnetic drag, even micro-collisions with solar particles. The 9th was a single word: artificial. It carried no elaboration, no supporting data, and no author signature. Yet its presence, on an internal NASA document, was enough to ignite the firestorm. Mainstream scientists recoiled. Artificial, from whom? From where? The idea of an extraterrestrial construct maneuvering within the solar system wasn't just improbable. It was professionally suicidal to endorse. The backlash was immediate. Prominent astrophysicists went on record dismissing the hypothesis as narrative creep, a product of human pattern-seeking and media sensationalism. "We've seen this before," one ESA researcher told a closed symposium. "Anomalous doesn't mean alien. It just means we don't understand it yet." But not everyone was content with that explanation. A small vocal minority began to analyze the data with a different lens. They argued that 3I Atlas wasn't acting randomly, it was responding. The deceleration wasn't uniform. It was timed, occurring at intervals that aligned suspiciously with observation windows from Earth-based arrays. "It's as if it knows when we're watching," one researcher wrote anonymously on an internal NASA message board. Independent analysts outside the agency amplified the mystery. Using publicly available orbital data, they modeled 3I Atlas's path and discovered subtle oscillations, minor but consistent course corrections, almost like calibration maneuvers. That detail alone shattered the theory of random outgassing. The movements were too symmetrical, too controlled. The debate began to spill into the press. Scientific American published a cautious editorial titled "The Puzzle of Atlas," calling for transparency and peer collaboration. Meanwhile, fringe outlets went further, proclaiming that NASA was covering up evidence of an alien probe. YouTube channels and Twitter threads turned the story viral. In less than a week, 3I Atlas was trending alongside Oumuamua and Artificial Object. NASA, cornered by speculation, held an emergency briefing. The tone was firm, almost defensive. The object was natural, officials said, its behavior a fascinating but explainable deviation. Yet, even during the broadcast, astronomers watching the live feed couldn't ignore the tremor in their spokesperson's voice. They were defending an explanation that no longer convinced them. In the background, classified discussions were underway. Some within the Pentagon had taken an interest, not because they believed it was alien, but because they couldn't rule out something closer to home. Could 3I Atlas be a rogue technological artifact? A failed probe? A relic from a civilization long gone, drifting between stars until it found the warmth of a sun again? Theories multiplied. Some posited a derelict interstellar sail, ancient and inert, reactivating under solar radiation. Others suggested a probe built by a civilization whose technology operated beyond known propulsion principles, electromagnetic or gravitational field manipulation. A few, the most audacious, imagined it as a sentinel, a device programmed to slow and observe upon encountering intelligent life. Inside universities, graduate students built simulation models late into the night, testing scenarios that skirted the line between science and science fiction. Every outcome ended the same. If natural processes couldn't explain 3I Atlas's motion, then something else had to. But while the theories spiraled outward, a different kind of silence grew. NASA's public data portal began delaying uploads. Observatory feeds were rerouted. Anomalous readings disappeared from public access without explanation. For those watching closely, it felt like the story was being pulled inward, away from the eyes of the world. In scientific circles, the turmoil reached a breaking point. Careers were threatened, reputations fractured. Conferences avoided the topic. Researchers stopped replying to press inquiries. And yet, in private, they all asked the same question. If this isn't natural, then what is it doing here? Even among skeptics, one truth had become undeniable. 3I Atlas was performing with intent, or at least the illusion of it. And intent, in the language of the cosmos, was the most unsettling variable of all. For now, the official stance held firm, an unexplained but natural phenomenon. But behind the polished statements, the silence said otherwise, because every time they recalculated its course, the numbers repeated the same impossible fact. Atlas wasn't obeying gravity. It was negotiating with it. Echoes from Oumuamua to understand why 3I Atlas terrified scientists more than it amazed them. One only has to look back to the winter of 2017, when another object from beyond the stars had slipped silently into our solar system and left behind a wound in NASA's confidence that never fully healed. That object was Oumuamua, the first confirmed interstellar visitor. It arrived without warning, without precedent, and for a brief chaotic moment, humanity stared into the abyss of the unknown and saw something looking back. Oumuamua had been strange in every measurable way. It moved too fast, spun too irregularly, and reflected light as though made from metal, not ice. It showed no tail, no gas jets, no signs of being a comet, yet it accelerated slightly, as if nudged by some invisible hand. The scientific community wrestled with that anomaly for years, dividing itself between the cautious and the bold. The cautious called it a fragment, a shard of rock shaped by cosmic violence. The Bold, led by astrophysicist Avi Loeb, dared to suggest it might be technological. NASA never forgave that suggestion. Publicly, the agency dismissed the alien hypothesis as reckless speculation, but privately it haunted them. Oumuamua had slipped away too quickly to study further, vanishing into the dark before telescopes could catch another glimpse. It was a mystery unresolved, and unresolved mysteries have a way of echoing in the corridors of science. So when 3i Atlas appeared, the resemblance was impossible to ignore. The same interstellar origin, the same defiance of cometary behavior, the same inexplicable acceleration, and only now reversed. Oumuamua had sped up as it left. Atlas was slowing down as it arrived. The symmetry felt deliberate, almost poetic, as if the two objects were chapters of a story humanity had only just begun to read. Inside NASA, old memories stirred. Many of the same scientists who'd analyzed Oumuamua now found themselves staring at a familiar pattern, the same irregular brightness, the same precision in motion, the same quiet sense that something about these visitors wasn't accidental. But this time the instruments were better. The tracking networks were ready, and what they found, they could no longer attribute to error. Among the researchers, a dark joke began to circulate. Maybe Oumuamua was the scout, and Atlas is the messenger. No one said it publicly, but the thought lingered in every meeting, every encrypted message thread. What if these weren't random cosmic drifters? What if they were part of something larger, a pattern of observation or contact unfolding across decades? A few bold voices suggested that Oumuamua's sudden acceleration out of the solar system might have been the same phenomenon in reverse, an intentional maneuver to escape detection, now mirrored by Atlas's slowdown to remain within it. The thought was unthinkable. Two interstellar objects, both behaving as if guided by purpose. For NASA's leadership, it was déjà vu and dread. The Oumuamua controversy had bruised their credibility once. They wouldn't risk another. Public statements about 3i Atlas were sanitized, scientific terms chosen like armor, non-gravitational influences, thermal recoil forces, anisotropic radiation effects. Behind those phrases, though, was fear. Fear of what it would mean if the laws of motion weren't enough to explain what they were seeing. In private, senior analysts whispered what could not be written. Oumuamua hadn't been an outlier. It had been a warning, a hint that humanity's solar system was not as empty as it appeared. And now, 3i Atlas had arrived to remind them. The shadow of that first encounter still lingered, shaping every decision, every press release, every refusal to speculate. Because the truth was too dangerous, too destabilizing, too vast to confront. And as the data came in, clear, precise, undeniable, one thought echoed through NASA's quiet halls. Maybe Oumuamua hadn't left us after all. Maybe it had been waiting for company. What Comes Next by late August, the silence around 3i Atlas had become louder than the data itself. NASA's official updates grew sparse, and the last public orbital report, once updated daily, froze without explanation. Amateur astronomers who tried to track the object noticed something disquieting. It wasn't where it should have been. The coordinates drifted from prediction, as though 3i Atlas had quietly stepped out of the spotlight. Inside closed networks, however, activity spiked. Private observatories received encrypted requests to cease live telemetry uploads. A small European team, known for its meticulous sky surveys, claimed that they'd intercepted faint radio emissions in a narrow frequency band near 8.4 GHz, a range commonly used for deep space communication. The signals were rhythmic, structured, and repeating every 47 minutes. Within hours, their report was removed from public access, and the researchers stopped responding to inquiries. Days later, fragments of a classified internal memo surfaced on a private server. It mentioned narrowband anomalous returns consistent with artificial modulation. Those few words were enough to ignite another wave of speculation. If true, it meant 3i Atlas wasn't just maneuvering, it was transmitting. NASA and the European Space Agency both issued denials. The radio noise, they said, came from terrestrial interference, satellites, ground radar, even weather balloons. But the timing was too sharp, the pattern too deliberate. The same frequency spike had been detected once before, briefly. In 2018, during Oumuamua's departure, whispers began to form a question that few dared to voice aloud. What if we're not observing them? What if they're observing us? In the months that followed, independent data analysts noticed an eerie synchronization. Each time Earth's rotation brought major ground telescopes into alignment with 3i Atlas's predicted vector, the faint signal reappeared. Not stronger, not clearer, just there, like a pulse waiting to be noticed. The official story remains unchanged. 3i Atlas, an interstellar comet, has left the inner system and is now receding into deep space. But those who've seen the raw data, who've stared at the patterns hidden between noise and signal, tell another story quietly. They say it didn't leave. It just went silent. And somewhere beyond Mars's orbit, drifting in the cold and the dark, an object still waits, patient, deliberate, and possibly aware, because maybe, just maybe, the sky has been watching us all along.